Okay, so good evening, guys. So welcome back. So we will continue our day 7 session today. So today the date is 25th of July 2024, and the timing is 8:36 p.m. IST. So guys, before we start discussing, just one information. Like we already agreed to to attend the class on this weekend, right? Saturday, Sunday, right? Saturday and Sunday. So hopefully this weekend. Uh, Only for this weekend, not like every weekend. This weekend, Saturday and Sunday, we will be having a session from evening 4 p.m. IST to 6 p.m. IST, right? So we have agreed for this timing, and we all can attend this session for only for this weekend. From next weekend, I'll not be taking the class. Okay, I have even thought I will cover few more things extra than what we have in part A. Say for example, like in the weekends, particularly only on Sundays, just for 1 hour, just for 1 hour. Not I'll not take more than 1 hour. Not next weekend, next to next weekend. Only Sundays. I'm planning to take. I'm planning to take PowerShell scripting. Just one hour till we complete this course, right? We will be taking it up. Just one hour. Just attend whenever it is. I mean, whenever you feel the slot. Okay, I'll take Sunday morning. Just 1 hour, 9 to 10. We attend it. We will try to attend it every Sunday. This is not there in our course content, but I'm planning to take this one, PowerShell script, because one of the person he had asked me about this, and I said I'm not covering. But then I thought that like let me also start taking this PowerShell script, because I'm also started updating the PowerShell scripting now. So we will try to cover some basics part on PowerShell scripting and how to write all those things in our Windows platform, right? PowerShell scripting, we'll cover that. Okay, so this one, not this week, next to next week, maybe third week we will start, or next week itself we will start the PowerShell scripting. So is it fine, guys? Only Sundays, 1 hour. That's all. Only for 1 hour, not more than that. By the time when we had completed this whole course, we would have completed around 16 to 20 sessions, right? So 20 hours is enough for us to cover basics on PowerShell scripting. Okay, thank you. So now, so in the day 6 session, that is yesterday's session, so we had covered a lot of things, right? We tried to understand some more details about like how exactly the shell works. It means that whenever we execute any command, shell will try to search in the path environment variable, right? So $path. So this is the path environment variable in through which the shell is going to search, or the bash shell is going to search for any command execution. So it means that whenever it is executing any command, it has to first search for the path. Now what happened, right? Once it searches for a path, if it gets the command, it will try to load that command and execute it. If it doesn't get that command in from any of the path which is mentioned in the $path variable, then it will say that command not found, right? So we saw that yesterday, right? By executing some commands like this, some unknown command which doesn't exist. See, you could see that we are getting command not found. So based on the path variable, it will try to search for that particular command. In this path, if it is not finding this command, it says that command not found, like that. Okay. And also we had discussed about what else we had discussed, guys? Can anyone recall? So we discussed about some of the commands, right? And also we had discussed about man page. Like whenever you are working for any command, you have to either go with the man page or info page, right? So few of the things we had covered in yesterday's session, right? And today's agenda, what would be our day 7 agenda? So today's agenda, so we will try to start. You remember yesterday I told that when I execute the command with the ls-i, right? You could see that you are getting some index number. For every file or a directory, you are getting some index number. So what is this index number? So how I got to know about this -a option? To the manual page. If I say man ls and enter, if you come down, can you see that? It prints the index number of each file. That index number is nothing but it's an inode number. Right? The index number is nothing but the inode number. So now, right now, when I try to run the command or execute the command, Guys, whenever you want to quit from the man page, what you have to do? Can anyone tell me? So I'm going through the
Q,
man page.
Q.
Yes. You have to just press Q, it will quit from the manual page. Right? Now, or else you can even run the info ls command, right? Info will give more information than the manual page. Yesterday, we just understood it. When I say Q, you are quitting from the info page, right? Either you can go with the man or info page for learning it. And yesterday, I added one more point, guys. Just you have to understand about the command as well as you need to understand about the options also. Every command in Linux or in Unix, right? Every command has an options, and always the option starts with a hyphen. It means that you have to give the command, give the space and hyphen and specify the option. This is the syntax you use, right? This is syntax. You cannot run like this. If you give like this, it is an error actually. Always you have to give option. After giving the command, you have to give space, hyphen you have to give, and option. This is a short notation. Sometimes you will have full notation. Like for example, ls hyphen fn node. Like this also you can give. Either short way or the long way. So long way usually people doesn't use it, right? They don't use it in the real time. I mean, when we're working in a system, why you have to type everything if I'm able to get the same output with the hyphen I, right? Why you have to type hyphen F and I node like that? This full form is not required, but still for a certain reason, when the developer have developed it, when they have developed this command, right, they have given both the option, short form and the full form actually. Okay, so it is not mandatory that you should learn all the full forms because we don't use it at all, and people also are not aware of this full form always, right? See, if I do a ls-b, it will show the block, it will show the what is it, hyphen b, escape print C style for non-graphic characters. Okay, fine. But I was thinking that if you use I don't think so there is any option to display the block device, right? No block device. But if you do a ls-l long listing, in that you can check if it starts with a B, it's a block device file. So now, so people doesn't use the full form as I said earlier. Okay? So we have to always use only the short form because that's how the people use on day-to-day activity. Okay, now coming back here. So what we discussed, we said that ls-I will show the inode number. Now the question comes, what exactly this inode number is all about? So the inode number is something like, say for example, I think some of you already know this. So we have this, same thing, we have user space and the kernel space, right? User space and the kernel space. So I'll just say user space and yes, kernel space, right? And here what happened? The OS or the kernel will be up and running. You know that during boot up time, the kernel is going to come up, right? The kernel is going to come up, or the whole operating system is going to come up. And here what happened? Your user will log in, right? The user is going to log in. Any user, it could be Rajesh, Mahesh, Ramesh, or it could be root user. Any user can log in, right? So whenever a user logs in, right, as soon as you know that whenever a user logs in, a user will always get a terminal, right? You will get a terminal, terminal, terminal. So this terminal, whatever we got it here, this exactly it's a terminal, and this is, we call it as a pseudo terminal, or we can call it as a virtual terminal, right? We discussed this also yesterday. Virtual terminal or pseudo terminal, basically. Virtual terminal or pseudo terminal, right?
Bash also.
Yes. Yes. Pseudo terminal. So when we are getting a terminal, always the terminal we will get some terminal number. How we are going to get that information? By executing tty command. So if you execute a tty command, you are going to get the terminal number. So this is the pseudo terminal /dev/pts/0, right? Now what happened? Right? This terminal is associated with the bash shell. So bash shell, bash shell will always get associated with the terminal because bash itself is a process, and that process is running in a foreground. So we say that the process is running in a foreground, and that process is associated with the terminal. It means that whenever user logs in, by default he will get a terminal, and the terminal is associated with the bash shell. That's how we say that whenever user logs in, by default, he'll be sitting on the top of the shell and he'll be working. Right? Now the user, what he's doing, right? He is using a command by name touch command. Just say, for example, if you use a command touch, I will use some name. Can anyone give you a name? Let me check it. Admin, Afzal, Daya, right? Dayanand. So in short, I'll just say Dayanand. So if it does touch Dayanand, what will happen? That touch is going to create an empty file, or it's going to create a 0-byte file, we say. Right? So whenever it does a touch command is going to create a file. That's correct. But what exactly happened that when he creates a command, he creates a file with the help of a touch command, a file is get created. This file will get an inode number. What is it? It gets an inode actually. So whenever you create any file or a directory or any type of file in Linux. So yesterday we said that I just told that there are 7 types of files are there. What are those files? Normal file or regular file, directory, hard link, soft link, character device file, block device pipe file, FIFO file or the pipe file, and finally socket file. So these are the 7 types of files which a user can create in Linux. So is there any other files apart from the 7 types? No, these are the only 7 types of files you can find in Linux or in Unix. Now, whenever you create any type of file, you create a character device file, you create a block device file, you create a directory, you create a normal file, you create a pipe file, you create a socket file. Whenever you create any type of file, an inode will get created or inode will get assigned to that file. Who is going to assign inode to you? Inode to that file? The kernel is going to assign an inode to the file. Again, if you ask Rajesh, within the kernel, which is that subsystem? Yeah, that subsystem is file system. What is it? It's a file system. File system is the subsystem of the kernel which assigns an inode to that newly created file or a directory or any type of file. Right? So this inode will have some information. What is it? It has information. What are the information it has? It has information about, right, when the file was created, when the file last modified, when was the file last changed. So if you see it, when the file was created, when the file was modified, when the file was last changed, this we call as a timestamp. What do we call? We call it as a timestamp. Timestamp will give the information about about the 3 major timestamp, like creation time, last modified time, and the change time. What is it? We will see in some time now. Okay. So these are the information which you will find within an inode actually. Right. And it also has one important information on the inode number. Right. It also have information about pointer to the data blocks or addresses of the data blocks. It also has information about who is a user ID who created it, who is a group ID who created this file or a directory or whatever. So these are some of the information which will be held within your inode. It means that inside the inode, you'll find all this information. And this information which is there within an inode, we call this as a metadata. What is it? We call it as a metadata. So if somebody asks you, what is a metadata in Linux or in Unix, you have to tell that the information which is there within an inode, we call it as a metadata. So what is that information? You will say that, sir, all information about your file, like when was a file created, when was the file last modified, when was the file last changed, all those information. Apart from that, inode number will also be there. Apart from that, pointer to data blocks or address of the data blocks, user ID, group ID, all such information which will be there inside an inode. So if somebody asks you, okay, I understood inode is there something, but what exactly is inode? See, inode is something like you said that whenever you create any file or a directory, an inode will be assigned to that file or a directory. Okay, that inode has all this information, and that information we call it as a metadata. But what is this inode? You'll say, sir, it is something like a small block, Say, for example, 512 block. 512 block size, right? 512 block size is a disk size a disk size is allocated okay, it allocated to it, and this 512 block disk size whatever is allocated, this we call it as a inode. Okay, it means that Rajesh, within a file system, you have some disk space. Is that disk space 512 bytes or 128 bytes of disk space, which we call as an inode? Yes. Oh, it means that in a disk, do you have n number of inodes? Yes, you have n number of inodes. Who manages all these inodes? The file system will manage it. And what is that file system? In Linux, we have so many file systems like ext34 file system, ext3 file system. So those file system will manage these inode numbers. Okay, means inode, within inode, we have inode numbers. Okay, so it means that Rajesh, what exactly it means? You will say that, see, this is your file name. What is the file name? The file name is Dayanand, because with the touch command you created it. Dayanand, right? Dayanand. Now what happened, right? When you create a file, a inode will be allocated for your file. What is it? An inode will be allocated for the file. And this inode has some number. What is it? So for example, if I go here and if I use a touch Dayanand, and if I do a ls, I cannot see the inode number. If I do ls-i and give the file name Dayanand, you see here, it gives this number. This is nothing but your inode number. So now what happened, right? Now, whenever you create a file or a data or what type of file is, an inode will be allocated. So what it does is it actually basically the operating system or the kernel will create a link between a file name and that inode actually like this. This is a link it will generate it actually. What is it? It will generate the link actually. It will generate the link. This is the link. So now the question comes, okay, fine. I got you what you're trying to tell, but why we need this inode? Do we really need this inode as an end user? We don't really interact with the inode because that this inode is managed or maintained by the kernel. Kernel needs this inode. Why? Because that whenever user want to do any operation onto this file, it has to refer to that file with the help of an inode and with its inode number. Okay, it means that Rajesh, whenever kernel is doing any operation onto any file or a directory, it needs an inode number. With that, with the help of an inode number only, the kernel can do a read and write operation onto this file. Without a inode, kernel cannot understand what is a file. So kernel doesn't understand whether that file is a directory, whether the file is a normal file, whether the file is a hard link, soft link. For it, it treats everything as a file. Even character device file, block device file, it treats it as a file itself. Right? Even the socket file, socket file, or else pipe file, any type of file which the kernel want to do operation, it treats everything as a normal file itself. In case of Unix or Linux, the concept is same. So why? Because that whatever the basic operation, what you do onto a file, say for example, this is a file and you're doing some basic operation onto the file. What kind of operation you do? You say that, Rajesh, I want to read that file. That is some one operation. I want to write into the file. Right? I want to even do some modification of the timestamp, right? Or else you want to delete some content. That is nothing but your modification itself. So you are doing multiple operation onto the file. You want to change the permission to the file. You are, as an end user, I do interact a lot of things I do onto a file. So how exactly the kernel can understand, okay, this is a file which a user wants it to do all kind of this read write operation, everything. It can only do with the help of an inode number. And that inode is everything is managed inside this kernel. So within a kernel, you have file management, and that file management is a software that will manage this whole managing of all these inodes and its inode number. So now you say that, Raja, if I remove this file, Dayanand, I'll go to this system here, and you could see that if I do rm Dayanand, what is happening, guys? You are removing the file. It means that you're deleting the file. So what you mean by deleting? Deleting is nothing but you are actually removing a link between this file name and the inode number. This link is lost. So when you're doing a RM onto the Dayanand, it means that you're removing that file. It means that you're actually deleting the link between the inode and the file name. Is it clear, guys? Did you understood whatever I said? Any doubts you have?
Yes, sir, I understood. Yeah.
Abhishek Kumar, do you have any doubt?
No, sir.
Our another Abhishek Gangrudi?
No, sir.
Okay, great. Milan?
No, sir, no doubt.
Okay, good. Are you guys making me happy by saying? They're saying no doubt.
Good. I have a question. Not you making you happy now.
Okay.
So once the link is deleted, which
Hmm.
means the information or metadata stays in the memory.
Now, what happened when you are removing a link? Actually, you're losing the link. Still, what happened? This metadata exists because this metadata is maintained by inode only. It is something like when you're removing a file, this inode is released by the kernel and it will be sent to the free pool.
Okay, so it can be overwritten by another inode or when
Yeah, it
somebody
means that
creates.
whenever any other new file is created, if this inode is free, it can be allocated. Now what happened, right? There are some third-party softwares or tools are there. You can recover back the deleted file also, right? So can you Google it out? Something known as a debug fs and yeah, debug fs, and try to see what exactly debug fs does. That command, is there any way to recover a file? Can you just search and let me know later after some time? Is there any way? Suppose I remove a file, is there any chance to recover it? Yes, there are some third party tools are there. By using that, you can recover back the deleted file also. It means that if as soon as you remove a file, right, if you run a command, something a debug fs or something like that, you should be able to recover back that deleted file. So it means that whatever the inode you lost out, you have to recover it and you have to read the whole metadata to read all the data what was there in that file. So it is possible, right? In case of ext3, even this feature was there in ext2 also, very older file system. ext2 was there in early 2000, actually 2002 at that time. ext2 was there, then later ext3 came, now ext4, like that. This is some. So there are many other external tools are available with which you can recover back a deleted file, but you should instantly do it, because unless until that inode is not allocated to any other files, there's a chance to recover that file. If it is allocated to some other file, you cannot recover that file. Okay. Fine, good. So what I'm trying to tell here, that actually that this is very important, this inode number, because the kernel does all the operation onto a file with the help of this inode number only. So what operation? Read, write, fcntl, ioctl, there are a lot of operations are there through which it can do an operation onto a file. So those operations and all it will do, the kernel will do with the help of an inode and with the inode number. Good, right? Now,
Yeah, so Rajesh, I have a question actually.
yeah, good.
So as you told, so like we are recovering the file from whenever we delete. So after deleting the file, how can anybody get the inode number actually?
Yeah, that's not like there is a utility is there, through that you have to give the name of the file, right? You can recover it, or else if you remember the inode number or somewhere the inode number is maintained by you or by others, right? With that inode number also you can recover that file, deleted file.
So basically, Rajesh, it checks like the inode is not overwritten and the sector where the real data block is available, that is
Yeah.
not written. So
Yes.
it looks for the stale inodes and
Yeah.
it contains the metadata and exactly the location of the data block. So it
Yes.
just maps it to that place and then it recovers the file. But if
Yes.
that inode is occupied, then it will not return
Yeah,
any.
almost. Yeah, yes. Yeah, you're right, actually. I have did all this long back in 2006, 2007. I removed a file and all, I don't know. I'm asking if our
Yeah,
Mahesh sir is there. Yeah.
same kind of concept is on Windows as well. You have a software called Recua
Hmm.
that works similarly.
Yes, yes.
The same
Right.
logic works there.
Same, sir. Same, same. Yeah. But this concept of inode is not there in Windows. We have a something known as a FAT, file allocation table.
Right, right.
It maintains a file table to to check in the particular folder what are the files or the folders exist actually. So it manage a table kind of a thing. Here what happened, right? There is nothing like that actually. It always get associated with the inode actually. And this inode is of 128 bytes. Now I think they have increased it to 512 bytes. You can even check for the inode size. What is the current inode size? What is the inode size? Earlier it used to be a 128 bytes. Now they have increased it to something more than 512 bytes or something. Where is it? Somewhere, if you search, you will get it actually. Uh, somewhere you will get it, sir. 512 bytes only. 120. It was the default size is 128 byte. In ext4, the default size is 256 bytes. Yeah. So like that, ext4, no, ext5 also we would have increased 512, something like that. Because every time, right, even I know that this meta information also, metadata information also will be keep growing actually. So what I was trying to tell that, my sir, are you there?
Yeah, I'm here.
Yeah, do you remember, like we discussed about one of the project where, like we can set up the timer expiry for the file?
Yes, I think there was a kernel module for that.
Yeah.
Right,
Yes,
right,
yes. So what we had did means that project I got, and I think we both sat and discussed, right? The whole code we went through, right?
right.
Kernel
We
module.
had the entire code and we went through.
Yeah.
The
So
new
what?
kernel module was developed for that to set a
Yes.
particular timer.
Yeah.
What essentially even without that particular project, in order to recover a file, now if you have the inode number, the first step would be ideally to unmount that particular file system on which the file was created to ensure that the data blocks are not overwritten. To ensure that the data blocks are not overwritten, you unmount that particular file system, and then probably reattach it and run that either debug FS or there was this other one, no, ext4 magic or one of
No,
these.
no, no. See, debug FS, I have did, sir. I remember debug FS was the thing. One more was there. I don't know. Tune E2FS, tune FS.
Tune E2FS, yes.
Yeah, tune
Tune
FS.
to FS was there, but I don't think that would help you
No,
to
no. I
recover.
mean, I'm just saying I don't remember whether this command is used for that itself, but debug FS I remember. So that's the command which I used it actually to recover a file. Tune E2FS actually. So tune maybe
This
it
won't
might
work.
be this won't work actually. It might be like increase the size. I think actually increase the size of the device or increase your partition, something like that. So guys, sorry, don't worry. I will tell you other things and all whatever I'm discussing. Okay. So what we did as that project, like suppose like I have a file, like I have created a Dynan file just now created, right? I can set a timer expiry for that file. Say, for example, after 30th of this month, that file shouldn't be exist. It should automatically, it should get removed actually. So we had created it. I still think I have that document with me. I think, Mahesh sir, even you have that document I have shared with you, right? So we followed that article or the document to do that project actually. So fine, that was no, I just remembered that. That's what I recalled. So, okay. So, what I'm trying to tell that, guys, Abhishek was also right what he said. In Windows, we have that third-party tool. Similar in Linux also, we have some external tools also we are having. Using that, we can do it. Debug FS, you try to search, you will get articles where they are given a step of how to recover a deleted file. It's a simple process, like 3-4 steps you have to run. You can recover that file, and that when you recover that file will be like it will be changed to some swap file .swp like that. If you try to recover it, and suppose I remove the Danan file, I removed it. When I recover it, when you do ls-a, you could see that there will be a file will be recovered with the name .danan.swp like that. Here, if you do so it starts with the dot. So then it means that you have recovered the file. Then you can open that file and you can view the content, whatever it has been deleted. Yeah, correct. ext2 and delete can be used. Yes, there are many things have come up now. Even I'm not aware of, but I'm just saying very long back, this was a command which was used, debug FS. Okay, fine, guys. That's fine. Okay. So now coming back here. So, yeah, that's how that inode concept works. So when we are going here, if you do an ls-i, you could see that it will show you the inode number. Apart from this, there is one more important command is there. Let me create the file then and again. Right? I created with the touch command. If I do an ls-i, it will show you the inode number also of this Danan. Suppose if I run a stat command onto that file, stat command also will give an inode number like this, but it gives some other information also. Like it'll also give you the how many hard links are there, what is an IO block, is it a regular file, it's a empty file, and these are the three important timestamps which I was saying, which the inode manages. access time, modified time, change time. These are three important timestamp. Access time is when was the file last access. Suppose you opened a file by using cat command or va command, this change will happen. This timestamp change will happen. Modified time, say for example, if you open a file, you have added some content or remove the existing content. It means that you are modifying the file, then this modified time will change actually. So whenever you are trying to open a file and whenever trying to do any modification, both these timestamps will get changed. Change the time is something like, suppose like you are moving this file from one location to other location, or you're renaming a file. So from Dayanand to Sadanand, you're renaming it, right? So I can rename it by using a move command. I can rename it, or else there's a command is a rename command. Rename command is there. Using that also you can actually rename the file. So if I'm renaming from Dayanand to Sadanand, then this change file will get changed actually. So sometime in interview, they might ask you how to display an inode number. You will say ls-i. Is there any other command to display inode number? You can say, yes, there's a command by name stat command. So by using that, it will also display the inode number. So here what happened, it is showing some extra information like what is the file name, Dayanand, size is 0, it doesn't have anything. Block size, how many number of blocks have been assigned? 0 block, because that file is an empty file, right? If I try to open that file, vi Dayanand, if I try to add some content into this file and then save it, and then do a stat on Dayanand, now you could see that it has assigned eight blocks for this Dayanand file. So as soon as you enter some data, automatically a block will be assigned for that, right? And the IO block size is 406 byte. What is IO block size and all? I will discuss in some time now, right? I will discuss it. Don't worry that I have to cover it. All this user ID, group ID, which user ID, which group ID has been created. You could see that Ubuntu is a user who has logged in. Every user has an user ID. How to print it? You can just execute a command ID. If you execute the ID command, it says that it is 1000 is an ID number, UID. You call it as a EUID, effective user ID or user ID. Even the group ID also shows you that by default, the group ID also with the same number. So Ubuntu, right? And it has some other characteristics. So every user in Linux has a ID. Every user account has its unique ID. We call it as a effective user ID, EUID. You can even display by executing command echo $EUID. It will show the same number, 1000. So you have to remember that whenever any user account is created in Linux, right, always a ID will be generated. That ID will be associated for that particular user. So now here, in case of here, when it comes back here, whenever a user logs in, so Ubuntu user has logged in here. Ubuntu user has logged in here. Ubuntu user ID is 1000. So it means that whenever you logged in, you will get the kernel, the operating system can understand, okay, which user has logged in. Oh, it is 1000. Oh, it means that he is a normal user. In this case, it is pseudo user only, but consider it as a normal user. Okay. Now suppose assume that Rajesh logs in. Rajesh is having user ID 1001. Oh, whenever Rajesh logs in, okay, he is 1001. Okay, he is a normal user. Whenever root user logs in, always his IDs will be 0. Now, if you go here, if you go to the system and if you do a sudo -i, you are switching to the root user. Sorry, sudo su-i. What is it? Su user. Sorry. So root user has come, right? If I do a ID command, can you say for the root user ID is always 0. Group ID is 0. Right? So now, so based on the user ID, the kernel can understand what type of user he is. So always what happened, right? From user ID 0 to 999. User ID from 0 to 999.
System users.
Yes, system user, right. From 0 to 999 system user, right. Above 999, like from 1000 to 35,565, 36,535 something. This, sorry, 32,765, sorry. These are the number of user ID. This will be for a normal users.
I think it is 60,000.
60,000 or, I mean, that's what the value will keep increasing. I'm just saying this is an older value which I'm giving, but above 1,000, right? And whatever the max value you have, right? All those are considered as a normal users IDs actually, right? So how to check it? Whether the user ID for the particular user, you have to open the file by name etc etc/etc possibility. This is the file you have to open, guys, and you could see that for the root user, the user ID is 0 and the GUID is 0. Similarly, for the Ubuntu, here you could see the user ID is 1,000 and the group ID is also 1,000. So this is one of the way, or else you can just execute the ID command to verify what is your ID. Right now, go back here in the stat command. When we run the stat command, it is showing you user ID and group ID. It means that whenever you're creating a file, that file is also associated with some user ID and group ID. It means that which user has created this file and who is the owner of that file. Okay, 1,000, that is Ubuntu user, he is the owner of this file. So always that file will be associated with some user, and that user is 1,000, and which is nothing but UID. To which group the Dayanand file belongs to? The group belongs to the same group ID, that is 1,000 only. By default, there is a group ID, group also there in Ubuntu. Through that only it it falls under that particular group. And these are the 3 timestamps like this. This is some extra thing which they have added now, right? When was the file created? Birth, right? That was earlier it was not there. Now it is there. And this is something like a device identifier. So because we are creating a file into the disk, this is a hard disk, this is a partition. So it is showing your device identifier 202. Suppose if I take a pen drive and I plug in, and I'm creating a file in a pen drive by using touch command, I have already mounted the pen drive. Later I will show you how to mount that pen drive. Suppose the file, your USB stick is mounted. So every device has a device identifier. So that device identifier, it will show some other device identifier here. Got it? So it means that the kernel also, the system also understands under which device identifier you are creating a file. Okay, good. Now, so, okay, that's all. Okay, and as I said, right, whenever you are learning any command, guys, suppose we are learning ls command, a minimum 5 to 6 options you should have a knowledge, or you should know how to use, or you should have a knowledge on minimum 5 to 6 options. Say, for example, if I do an ls is there, fine. If you do a ls-a, okay, it will also display all the even hidden files also. Hidden files are a directory, because there are so many files are a directory, starts with a dot. It means that those are hidden file or hidden directory. Similarly, like that, whenever I want to do a long listing, I want to display some more information apart from the file name or a directory name. Then when I do a ls-l, it'll do a long listing. So you could see that it is showing in the column wise 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns are there, and this 9 columns, right, are how you can bifurcate this 9 columns with the spaces, because in between there's a spaces here. So this first column is nothing but the permissions. The second column is nothing but the hard link for that file. The third column is nothing but user ID. Fourth column is group ID. Fifth column is the size of the file. Okay, and sixth, seventh, eighth, right? These are the timestamp. And the last 9th column is nothing but file name or a directory name. So long listing will give more information than the normal ls command. If you just run a ls command, it will show you all the files and directories. But when I do ls-l, you could see it will give a long listing. So a lot of people will always execute this long listing actually. Right? Now, whenever I want to reverse it, because recently I created the Dayanand file, right? So I want to reverse it actually. I'll do ls-lr. Can you see? LRT, sorry.
Rajesh, what's the timestamp actually? It is showing like 1657.
Yeah, this is, see, yesterday we created Afzal, right? So 24th of July, it is showing you, see, whatever the current time and date is there, right? Based on that current time and date only, it will create that file. See, this system, what we use, right? This is there in the UTC time.
Okay.
So based on this time only, it will give you the timestamp. It will give you the time.
Okay, yes, sir.
Okay. Okay, so good. So now, sometime what happened in interview, they'll ask, okay, I'm sorry, I'm taking Sadanand name. Sadanand, can you tell me like what is the second column of the LSFNL output? Sir, you will say second column is a link, sir, hard links. Okay. Why we have a hard link? What is a hard link? They'll ask you like that. Right. Or else they might ask you, what is the first column, sir? You will say it's a permission. What is the dash, dash, dash? There are some 10 dashes are there. What is the first dash? So first dash represent what exactly the file is all about. If the first dash is empty, if it doesn't have any value, then it is a normal file or it's a regular file. Whenever the first dash is a D, it's a directory. Whenever the first dash is B, it's a block device file. Whenever the first dash is C, it's a carrier device file. Whenever the first dash is uh, P, it's a pipe file. Here we don't have pipe file. Suppose I want to create a pipe file, I'll say sudo mkfifo my FIFO. So can you do here? You have created a FIFO file. Can you see FIFO file? Now you could see that it starts with a P. So always the first dash of that first column, right? It represents what type of file it is. If it is blank, means it is a normal file.
Link 1 is missing, sir. Soft link, soft link.
I mean, I have not created any soft link, but this is the hard link actually it's showing you. That is showing you the hard link. What is it? We will see now. Okay, so what I'm trying to tell you guys, whenever you are trying to learn any command, please learn even the options also along with that. Just don't learn only commands, because that command plainly will give you the output. But when you want to play around with that command more effective way, right, at your workplace, you should know the options also, because options will give some kind of a filtering method for the end user. I want a particular output. I don't want only files and address. I want some extra thing. I want to display with inode number. So ls-i. Okay. Whenever I want to display a file, right, it should show some symbol to me, so that with that symbol I can understand what type of file it is. Oh, ls with hyphen capital F option. Okay. Oh, whenever it's end with a slash, oh, it means that it is a directory. Whenever there is something like a pipe symbol like this, oh, it's a pipe file. Whenever there's a directory, it's a slash. Right. Apart from that, it is not finding anything. Suppose you have some executable file. Say I will make that, I will give the full permission for Afzal. Now I will run the command ls-f. Can you see star? Oh, it is an executable file. So with this -f option, end user can understand what type of file it could be. Or else he can even do ls-l to do a long listing, and he can just check the first letter, whether it's a D, P, F, or L, or D, or blank, like that also. With that. So anyway, you can understand what type of file it is. Oracle's yesterday I told, right, file command, file Afzal. It's an empty file. File Rajesh. It's a directory. File my FIFO. It's a special character block device. Pipe file, named pipe, FIFO file, we say. File my block. Right? It's a block device file. Like that. File command also is being used to check what type of file it is. Am I clear on this, sir? Till here. So now you have to make a habit of learning even the option along with the command. Please always make sure that you have to learn, guys. Without option, you cannot really enjoy working on that command. You have to know option. How many options, Rajesh? Because there are so many options are there. It starts from A, B, C, D up to Z. Do you think that all 26 options you will be using in our day-to-day? No, we will not be using. Hardly 4 or 5 or max 6 options we might know for every command, not more than that. Even many people only know 2 or 3 options. That's all. Many other options they doesn't know. When they're working in a system, they'll Google it out to get a particular option. Then they'll use that option. Otherwise, hardly people don't even use effectively many options in a day-to-day work actually. So as and when you're working on to the command, you go to the manual page or you go to some article, there you will learn some options, extra options, which have come up or which is already existing. Try to check what that option does and try to execute and see the output and try to understand, okay, with this option, I'm going to get this output. Okay, because you need to practice and you need to remember it. So this is what, so every time, guys, now you will see that I'm executing some commands. Along with that commands, I'm executing some options also. Because to make you understand, okay, options are very, very, very important. We have to learn with option. Now, the next command is something like a date command. I will revisit this with ls-fnl first output. This is the permission and this is the hard link. I will come in some time now, but let us see some other commands. What are the other commands? You know that we have a date command.
Rajesh,
Yes. Yes, Ram.
what is the use case of FIFO and block files? Like, do we use frequently that one or?
Yes, I'm coming to that.
similarly
When I'm teaching the types of files now, in some time, I'm going
Okay.
to come across with all these things.
Sure, thanks.
Okay, Ram. Thank you. So I execute the date command. Date command will show the current time and date. Current time and date. So it will show the system time actually. Right? It will show the system time. What is the current time and date? It will show you. Suppose you want some, apart from this, you want any other any other command, any other options. You use the command date with the hyphen capital I option. You could see that it will show the year, month, and the day. With that format, it shows you. Sir, can you explain about the command arguments and options? Means which will come first? Example, please. Command and the arguments, man. As I said, this is the command. Arguments or the options. With the hyphen, it always get attached. Hyphen and then give the option. This is the only. This is synapses or this is a syntax. If you do a man of ls, see ls option and the file. So that option always starts with the hyphen like this. See, can you see all the options starts with the hyphen only? You cannot use. We cannot pass the option without hyphen. You have to pass hyphen. That is mandatory. So if you do a date with a hyphen capital I option, see, it will show you like that. So it will show in the format year, month, and the day like that. If execute date plus percentage capital Y, it will show the year. But I want to only display the last two characters like 24. Just use small y. Date plus percentage, it shows which month, 7th month, like that. D, date, today is 25th, like that. So like that, many options are there. When I'm teaching you some scripts, so you will see that I will be using the date options. I'll be using plus, percentage Y, M, S, like that. At the time, I will show you like why we are using that option. So this is very important in when you're doing automation, right? Many times you will be using this formatting also. Plus and percentage, I'll be using heavily in many of the scripts actually. Right?
Okay, sir.
And there's a command, there's a cal command. Cal will give you the, I think cal is not there. You have to install this package. So if you install the package, if you execute the cal command, you will get the calendar actually. So it will show the current month's calendar. So sudo apt update, you know very well that I have to first always run this command to update your repository, package repositories. That's what, and then run this command actually. So let me copy this command and keep it right. Sudo apt insert n cal actually. Right now I'm running this command. So it will install the calendar command. So by installing this, you got the cal. So when you run the cal, it will show you that this month's calendar. If you do a cal with the -3 option, -c, -3, then it shows you the last 3 months calendar, present, previous, present, and the next month's calendar. Right? So we already executed the PWD yesterday. It will show the current home directory. And we also saw what is, where, which, as well as what is, which, and where is, all those commands we checked, right? Any other commands is left? Okay, this much is sufficient. Fine. Okay, now, and who am I, right? Who am I? You want some more extra information, you can say who space am space I. You'll get some other information. Touch command we saw to create a file, right? mkdir to create a directory, right? So many commands are there which will be coming across now. Now coming back here, we saw that when I execute the ls with -l option. Yes, sir. Any doubts?
Sir, I wanted to know which help command I can search to know all these commands. Is there any help commands
See
So,
what happened, right? All these commands which are there in the system, right? This commands, right? There are multiple commands are based on the packages. When you install the package, there are many commands are there which starts the A. There are many commands are there which starts the B. There are many commands which are start like that. There are many commands are there which start with the Z, X also, Y also. Some commands are there which starts the M command. Now there is nothing like that where you can display all the you can display all the commands at a shot. There is no command like that. Say for example, let me clear the screen. How to clear the screen? I can execute the command clear command to clear the screen like this. Or else what happened, right? You can say shortcut Control L. Control L also will clear screen. See, Control L will clear the screen. So that's a shortcut. Now, if I try to do something like ls, I want a command to say ls880. I'll say A, and if I give tab, right? Or else L tab. Can you see that with the L, there are 102 possibilities are there. With that, there are 102 commands are there which start with L. If I say Y, it will show me all the commands which start with the L. Similarly, if I do A and if I give tab twice, it will show me all the commands which starts with the A. See, similarly, if I do a B and if I do tab, see, it will show me all the commands.
Okay.
So like this, only you have to explore it. There is nothing like that. Rajesh, I'll execute one command. It will show all the commands which start with A to Z like that. No, I can't display that. There's no command as such. If you know, please let me know. I will learn from you.
Yeah,
But
no,
as per my knowledge, there are no commands like that. It will display all the commands.
So
Yeah.
I think the question, Rajesh, the question was more of like, I think he is asking like how to know like what command to run. That was the question rather than all the command. That is what I got to know. I think
See guys, there are
you
many
are running
commands.
right. You are
Yes.
running multiple commands. So, and I think the people who are new to Linux, maybe they are thinking like, how you know all these commands? Okay.
Yes,
But
I'm coming to that. Yes, it's a good question, Abhishek. So let me clarify it, sir. When you are learning Linux, actually, as I said, right, like you need to know some commands. Like for example, the 80 most important commands which should be there on your fingertip. It means that as soon as I log into the system, or as soon as I log into the Windows machine, right, I should know minimum some commands. Like for example, ls command, date command, pwd command, right, and va command to create a file, move command to move the file, rm command to remove the file, right. Apart from that, I need to know some kind of other things like t command, pipe, how to use the piping, filtering. I need to know set command, awk command. I should know about the cut command, grep command, find command, awk command, right, test command. So what happened that when you log into the system, you should know some minimal commands to work comfortably in it. There is nothing like that. Okay, I will tell you the rule, Rajesh. Okay, now you created the server. This is a fresh new server I've created, Linux servers. Now you log in. Now you start. Point number 1, first run ls command. Point number 2, it is correct. You have to learn in a serial way. But what I'm trying to tell here that when you work under the system, you should be a little bit well equipped with some commands where using that command, you can comfortably manage to work under your system. That minimum is required. Without that, you cannot operate your Linux operating system. As an end user, I cannot operate. Now, whatever the command which I'm executing, I'm showing the class, these are the minimal commands we should know. Okay. Now, the second question comes, Abhishek, you might ask the question, like, Rajesh, how many commands are there total Linux? Sir, there are more than 5,000 commands are there. Now, do you think that you should remember all? No, it's not really required. There are many other commands are there which are not at all related to my work, which I have never used in my life. Then is there any necessity to learn all those commands? No, there is no necessity. Suppose, for example, you are assigned some work or some new project to you, where you'll come across with so many new commands which you never worked on it in your life. Then at that time, you'll get an opportunity to learn new commands. Then you learn, then you'll go to the man page, then you Google it out, you will search it. So as and when you're working the project, when you're working in system, and when you're reading the articles, when you're reading the books, when you're discussing with your friend circle, you're doing a lot of it automatically, guys, you'll be learning many commands. So I used to always say to my teammates that, guys, if in the whole day of our work, office work, if I'm not learning any new command on that particular day, that day is a waste for you. I used to tell this dialogue in my teammates for all my teammates where I was working previously, like Lumen Technology, right? I used to tell the same thing every day with everyone. Every day, if you're not learning any new command, they used to say, Rajesh, how we can learn all new? Explore it, man. I said, explore it. You doesn't also know if you're not using also on day to day, just go through it and you will get a lot of PDFs, books, articles where only Linux commands are there. I will share you those PDFs and articles also where you have 100 thousands of commands are there. You will say, क्या भाई इतना commands है भाई, ये भी command है, ये भी command है, ये भी कितना आपका दिमाग खराब हो जाएगा command देख देख के. File system के ऊपर ही आपके पास hundreds of commands है. Process management के related के ऊपर ही आपके पास hundreds of commands है, right? और उसके ऊपर आपका memory management के ऊपर ही एक 15 से 20 कमांड्स हैं, राइट? और आपका डिस्क में स्टोरेज के ऊपर कई सारे कमांड्स हैं. आप यूज करोगे, आप रेड इंस्टॉल करोगे, रेड कॉन्फ़िगर, रेड के रिलेटेड ही कई सारे कमांड्स हैं, एलवीएम के ऊपर कई सारे कमांड्स हैं, नेटवर्किंग के ऊपर कई सारे कमांड्स हैं. So what I'm trying to tell that whenever a user needs a command while when he's working, at that time only you will learn about new commands. Apart from that, whenever I want to comfortably work in a system, as soon as I log in system, I should start working comfortably, then 70 to 80 commands are required on your fingertip. Clear, guys? I think whatever I said now, it has clarified your doubts.
Yes, sir. Like for Linux administration, these are required.
Yes. Yes, obviously required. Linux administration will have a more knowledge than us. Suppose I'm a pure Linux administrator and you are a DevOps engineer. I will be having more knowledge on Linux than you because I have worked effectively in a system. I know you might be knowing 80 commands. I might be knowing 300 commands or 500 commands.
Okay.
Because in my whole life, I have effectively used many commands. So there are many commands are there, man. Only a root user or sudo user can execute it. You know, like admin can manage the whole system, right? He can even manage the servers. There are so many commands are there which are related to servers only. Server related commands like NFS server, FTP server, Samba server, Squidmail server, right? Postfix, Joomla. You take any servers, there are many commands related to that itself. Now, do you think that as a DevOps engineer, you learn all those commands? No, it's not required. I'm not a pure admin. Why I need to learn all so many server related commands? No, it's not required. For me, I am writing a pipeline. I am doing a build. I am working on a Docker. I am working on a Kubernetes. I am working on Ansible. I am working on Terraform. I need to know all the commands related to this DevOps tools. Why I need to know commands of all that related to the Linux administration? Not required. Tomorrow, if you get a project onto that where you need to configure FTP server or NFS server, then at that time you have to learn all those commands. Do you agree with this statement, whatever I said?
Yes, sir. Yes, sir.
Anything you have to add on the points? Mahesh sir, anyone want to add on something to it? Because I'm telling you something very serious, something very important. That's what, if any new points is added up, also is good for us, all of us. Abhishek, anything you want to add on?
No, so as you said, Rajesh, correctly, like it's not like that a company expects people like they should know every command. It completely comes. So Linux is that vast, like each area has network has lot of commands. If you're working in file system, it has lot of commands. So no one expects someone that but you should know just basic commands. Like when you log into Windows machine, what you do, you open a file, how to open a file, how to read a file, how to search something. Basic operations as you do in Windows, you should know in Linux. And then your work decides, and then Google is always there. So you every day, as Rajesh said, like learn one command every day. Your work requires you to learn one command every day.
Yeah.
It's like that.
Right, 100%. 100% agreed, sir.
Yes,
Good, sir. Good, Vasu. You raised this concern or you raised this point. Okay, thank you. Okay, let us move now. Okay, now. So we execute some couple of commands now. That's good. Now, guys, we'll take another 15 minutes more and then we'll give a break for 10 minutes. Okay. Now, coming back here. So when yesterday I told you about that, there are 7 types of files are there. What are those 7 types of files? So the 7 types of files are normal file, regular file, or we call it a white file or a black file. What do you call? Next is a directory, and the third is a hard link. Fourth is soft link. Fifth is a FIFO file, or it calls a pipe file. Sixth is a caret device file or the block device file, and seventh is a socket file. So these are the 7 types of files which we create in Linux actually, and it is very important that we should know. I mean, you might use or you might not use, but it's just like you should be aware of that actually. Now, the first very important thing is not but the hard link and the soft link, which we use always in our day-to-day activity. We use it actually. We'll try to understand that what exactly the hard link and soft link now. But before that, when I execute the ls-l option, right, it's a long listing actually. Right, this command will give you a long listing actually. Right, it will give you a long listing. What is that long listing? As I said right here, If you do an ls with a -l option, long listing, sir. So here what happened? There are 10 dashes are there. There are 10 dashes are there. So whatever I'm saying now, it's important. 1 dash, 2 dash, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 dashes are there like this. If you try to count here, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 dashes are there. The first dash represent the type of file. What type of file it is? Type of file. We already seen that if it is a D, sorry man. If it is a D, it's a directory. Right? Type of file. If it is a D, it's a directory. If it is a blank, it's a normal file. If it is a P, it's a pipe file. If it is a C, it's a character device file. Right? Or if say L, it is a soft link file. Right? Now the thing is that this first dash we can omit because that this is represent the type of file. Okay. Now, if suppose somebody asks you, Rajesh, like just check what is the first character, man. You can do LSFNL like this. See what I'm doing. Pipe it to grep of first characters. You could see that actually you are grepping for whichever having with the slash. Sorry, hyphen. So it's all normal file. Whenever you want to grep the D, see, cap D. It's a directory. Whenever you want to get like that, also you can pick it. Okay, this is the mychar, which is a character device file like this. So this I will tell you why we are using this. Just try to understand what I'm doing now. LSFNL pipe it to grep of cap C, something like that. Ashish and everyone, please mute guys yourself, please. If you don't have any questions, please mute yourself. Yeah, thank you. Now, right now coming back here. So this is first type. First dash is a type of file. Fine. Now the next or the rest 9 dashes, they are divided into 3 groups actually. Right? First 1, 2, 3. Okay, this is one group. 1, 2, 3, another group, and 1, 2, 3, third group. So this 3 dashes, it represents the owner. Who is the owner of the file? Owner of the file, or we call it user of the file. It will, right? And the second set of dash, these 3 dashes represents the group permissions. And this last depression, the last 3 dashes, it represents for others. It represents for others. So always for any type of file, any type of file means any type of that 7 types of files, any type of file it could be, there are 3 important permissions or 3 important group permissions. So what are those groups? What are those groups? So those groups are user or owner, group, and others. Always. You see, if you do an LSFNL, you have seen, right? If you see LSFNL, you could see for the directory also, you have some set of permission with 9 dashes. Even with the pipe file or FIFO file also, you have that 9 dashes. The value could be different. Okay, but you have that 9 dashes. But with that, this whole permission for the files are divided into these 3 groups. What is that? Owner, group, and others, or user, group, and others. Clear? Now, these 3 dashes represents the permissions. What are those permissions? Usually what happens, right? In Linux or in Unix, there are 3 important permissions. What could be the 3 important permissions? Read, in short we call the R, write, in short we call it the W, and execute, we call it as the X. These are 3 set of read, write, and execute. And the value where the Linux system gives is read is 4 value, 4 equivalent to 4, write is 2, and execute is 1. This is internally the Linux kernel or the system gives a value or assign this. Read is always the permission is 4. Write is 2. And execute is 1. So if you calculate, if you sum it out, 4 plus 2 plus 1, 7. Okay. It means something like if you want to get the whole permission, read, write, execution, the value should be 7. If you want only read permission for the file, only 4 is value. 4 will be set. Oh, it means it's read. Only write means 2 will be set. And only execute 1 will be set. Something like that. So it means that there are 3 important permissions are there. Read, write, execute. And apart from this, Rajesh, is there any other set of permissions are there? Yes, there are many other permissions are there, important permissions. We will see if I'm able to cover it out or cover it or not, or else in my channel, what I said, right? There is one permission management. There is a chapter is there in the video, like 1.5 hour video. There I have exclusively explained about other permissions also, right? For example, set user ID, set group ID, SUID, user ID, group ID, sticky bits. All these things I have covered in my video. Sticky bits permission. Apart from this, there are many other permissions are there, which are not discussed, but I've discussed about SUID, GUID, sticky bits and all. All the things I've covered in that video. I will give the video number. What is that video number? But there is something like a permission management. Is there one video is there with that name? So you can go through that video, 1.5 hour video, you get everything. Now, coming back here. So now, whenever you create a file, there always the permissions are assigned to these three groups actually: owner, group, and others. Owner is something like who is the owner of the file. See, I created by using touch command. I create a file by name Dayanand. Who created the file? Who created the file? Which user created a file? Ubuntu user created a file, right? By using touch command, Ubuntu is a user who logged in. He created a file. Now Ubuntu is the owner of this Dayanand file. So Ubuntu will always have the permission like this. What is the permission? He will have a read permission, he will have a write permission, W, and he will have a execute permission, right? Because he's the owner of the file, right? He will get all these 3 permissions. Because he is the owner of the file, because he has a full control on that Dayanand file. Hence, he can read the file, he can write some text in the file, and even he can execute also. Okay, this is okay. What about the group, Rajesh? Group, again, what happened, right? It is something like my wife comes under the group category. I will give her the read permission. I will give her the execute permission. I will not give her write permission. She cannot write anything into the file. She only has a read permission and execute permission. So this is the 2 permissions which will be given to the for the group user. So group user, my wife comes under the group category. Similarly, what happened? The others, my far cousin brother, who is outsider, right? Is my brother, is my cousin brother. For him, I will not give read permission. I will not give write permission. I'll only give the execute permission for him. So whenever you create a file, these 3 sets of permissions are assigned to any file or a directory or any type of that 7 type of file, right? When you create, these permissions are set. Now, what happened, right? Linux, what it will do that, how it assigns a permission to a file or a directory. Say, for example, if I go here, let me remove all the things, guys. Okay, I'll remove, let me remove. How to remove it? I'll just say rm-rf star. Everything I'm removing forcibly. I have removed the file. Now nothing is there. Suppose if I do a Dayanand, let me take some other name. Sorry, why I have to take always Dayanand? Let me take a file, any name. I can even take J actually. So J is the file which I'm creating it. Right. Let me create a directory. I will take a directory by name. What is the other name? Kailash. Kailash. I'm taking. I'm creating a file touch by using touch command J and the directory Kailash. Right. Now I will say enter. Now when you do ls-i, ls-l, you see for J some permission is given. For a directory Kailash, some permission is given. Now how the Linux understand what is the permission, default permission, and to give whenever you're creating a directory or whenever you're creating a file. How it decides? It decides based on the umask value. This is a umask value. This is one important question they'll ask in interview. How the file permissions are given, or how the permissions given for any type of file which you create. It could be hard link, it could be soft link, it could be a character device file, it could be a block device file, it could be anything. How it can assign a permission? So based on your umask value. Default umask value. Can you see here? The umask value is 0002. If you switch to the root user, the umask value will be 0022. So this is the default umask value, and this is for the root user, and this is the default user value for your Ubuntu user.
Sir, sorry, could you please explain again this umask command, sir?
Now, Vasu, what I'm saying that I created this file by using touch command. I created this J file.
Yes.
By using mkdir command, I
Yeah,
created this Kailash directory.
Kailash directory, sir.
When I do an ls-i, it is giving you, it is showing you that some permissions are being set, or some default permission is given for this J file, and some default permission is given for your directory. For all the user, owner, group, and others. This all 9 dashes which I said, right? It is for
Yeah.
owner, group, others. So it has given some permission, but I'm saying that how it has understood, how it has given a default permission. It has given the default permission based on the umask value, what is already there for that particular user. Because Ubuntu umask is 002, and the umask file for the root user is 0022. Here you could see it is 0002 0002 for a normal user or Ubuntu. For a root user, the value slightly changes, which is 0022.
So these are the default values, sir?
Yes, default value. If you want to do changes, you can even do changes also.
Okay.
Later, if you want it actually.
Like I think from chmod, I think, right?
No, you can run a umask only like this. For example, if I like that, so umask, I want same as a, if I execute the umask, you will say 0002, but you say, Rajesh, I want like a root only. Okay, no problem, 000022. So now you run a umask.
Okay.
You can change like that. Now, why it is needed for the change? Now, okay, you say that Rajesh, whatever the default is giving, I don't want the default, man. I want some other permissions. Then you can change it. But this is temporary, because if you reboot your system, this umask will be unsettled. So you have to go and edit on configuration file where it will be permanent. What is it? Again, later I will tell you.
Okay.
So Vasu and other, everyone else is thinking, what is it? Rajesh is saying, I will tell you later, I'll tell you later, I'll tell you later. Yes, guys, I will tell you all the things, all these dots you will get connected. You'll see all these dots I'm connecting later.
Okay.
Okay, good. Now, so let me get back to the umask value of 0002. This is what the default it has. Now, if you execute mask, now you could see that it has come back to the normal default 0002. Now, what happened, right? Whenever you are creating a directory, for a directory, I'm creating a directory. For the directory, always the value is 777, means 77 means 4 plus 2 plus 1, that is 7. 7 is for the owner, 7 is for the group, and 7 is for others. Now, how it decides what permission need to be given whenever you're creating a directory? Always what happened that whatever for the directory it is 777, you need to minus with the umask value. What is the first? This is a umask value. What you can do, you can just try to only take. You can just try to take the last 3 value. First one you can, as of now, you can just ignore it. I will tell you why we need the first 0 or the first digit value. But right now, try to understand that you are not using the first character or the first digit value. You will ignore it and ignoring it, and only the last 3 characters or the last 3 digit you are taking it. So now I will minus with the 0, 0, and 2, right? So if you minus it, what is the value you get, guys? You will get like 7 minus 2, 5, 7 minus 0. Sorry, I'm saying, I think. What is it? 7 minus 2, 5, 7 minus 0, 7, 7 minus 0, 7. Something like that. You got it. Right? This is the value you got it, right? When you minus it. What do you mean by 7 means? Read, write, execute for the owner. Read, write, execute for the group. Read and execute for the others. So it means that RWX for the owner, RWX for the group, and R and X for the others. Can you see? Can you match it here? Come over here. When you do ls-l, ls-l, and can you see a directory Kailash? See, read, write, execute, that is 7 is for owner. So this 7 for 7 you got. Read, write, execute for the group you got. Yeah, 7 you got. And 5 is a combination of read and execute, because 4 plus 1, 5. So read is there, execute is there, but write permission is not there for others. Can you see? It's a blank. So what he has did means, whatever the 77 permission is, 77 value there, that it has subtracted with the umask value, right? So this is how it gives this permission to, whenever you create a directory, always it gives this default permission 775, whenever you create a directory. Similarly, whenever you're creating any normal file, for a normal file, how it does it will have a value 666 minus with the umask value. What is the umask value? 002. So what is it? What you have to get? What is the 6 minus 4 is 4. All right. 6 minus 0 is 6. 6 minus 0 is 6. Right. This is the default permission, which is it is given for normal file. So I create a normal file by name touch J I created. For the J, can you see it is this is a default permission is giving. So what is giving 6 is not but it's a combination of 4 plus 2, 6. Read and write for the owner. Okay, read and write for the group and read for the other. 4 is not but read for the other. See, can you see? Read and write for the owner, read write for the group, and read for the other. Is it fine, guys? Do you have any confusion with this? So whenever you are creating a directory, always the umask value will be minus or subtracted with the value 777. Whenever you're creating a normal file, always the umask value will be subtracted with the 666 value. This is the formula you have to remember as of now. That's all. Nobody will ask all these things, but I'm saying for your information, you should know all these things. Sometimes they might ask, what is umask value? In some interview, they might ask. You have to say that.
Sir,
some
sorry,
default.
sir. Could
Yeah.
you please repeat the last statement? The 777 and 666 for directories
No.
777.
Now, what I'm trying to tell here, Vasu, right?
Yeah, yes, sir.
Vasu, what I'm saying means actually that when you create a directory, right? When you create a directory, it gives some permission like this. Now I'm asking a question, right? How it has created this permission or how it has given a default permission when you created a Kailash directory. Suppose I created a directory by name Vasu. Directory Vasu. When I do ls-ld Vasu, you see it is showing you the permission. You will ask how this default permission has given by to the Vasu directory when you created it. So it has given this permission based on this formula. What is that formula?
Okay, got it.
For the directory 777 minus the umask value.
Yeah.
So then you got 775. If I'm creating a file, 666 minus the umask value, 661.
Okay, sir.
Guys, any question you have?
Rajesh, I have one question.
Yes, Ram.
For directory, why we are taking 777 and normal file, why we are taking 666? Like, is there any...
Actually, what happened, right? Whenever you have a directory, sir, it always should have this 3 important permission: read, write, and execute. Right? So always a directory should have these 3 permissions for all the users. So whenever you want to get inside a directory, you should actually have a write permission and execute permission together. Both you need to have. Whenever you want to read the directory content, say for example, I will try to do CD to a directory, CD to the Vasu, but assume that if the Vasu having some more content, some other thing is there, and if I don't have a read permission, if I do ls, it says that permission denied. It means that whenever I want to read the content, whenever I want to view the content of a directory or a folder, you need to have a read permission. Whenever you want to CD, whenever you want to change the directory, or whenever you want to get inside a directory, you should have a write and execute permission. Both you should have it. So when it comes to a directory, always for the owner, group, and others, for all these 3, you need to have this default permission known as 777 for a directory. Because a directory is something like it's a special type of file which it needs some extra permissions. Now coming back here, what about this 666? Now, because we are creating a normal file should always have a minimum of read and write permission. Execute permission, if it is not there, it is fine. I can forcibly execute a file. If I'm a root user or if I'm a sudo user, I can forcibly execute a file, but minimum it should have is a read and write permission onto a file. That's what always you will have a 6 for the owner, 6 for the group, and 6 for the others. So this 3666, it should be minus with the umask value, you to get the default permission, what should be assigned to a normal file. Do you agree with this statement?
No, Rajesh. Actually, I'm having still some confusion.
What confusion?
You are saying that to write of a directory, we should have compulsory write and execute permission. Okay.
Whenever you want to do a CD, CD means change that you are getting inside a folder, then you should have a write permission and execute permission. Both you should have it. Whenever you want to view the content, you should have a read permission.
Okay.
Whereas a file, you should have a read and write permission. But if there is no execute permission, that is fine. You can forcibly execute, I'm saying. You can make it forcibly execute because you should be a root user or you should be a sudo user. Rajesh, if there is no root user, then there is no sudo user. If it is a normal user, then he cannot execute the file. You need to give an extra execute permission to execute a file. If it is an executable file or it is something like a script or a executable file, you need to give .x actually. But whereas a root user or a normal user, sudo user can forcibly execute even though it doesn't have X permission, which is but X. So that's the reason for the normal user they kept 666. That is a minimum permission it is required. I'm saying. So when they designed it, right, they started, okay, whenever normal file or any other file is created, let us give some default permission based on 6 value only, read and write only. Whenever you are giving a permission, you need to consider all the 3 permissions. And that's the reason you have to minus it 777.
Okay, just for changing the directory, we are just using 777.
Yes,
No
yes.
other reason, right? Compared to
see, obviously, man, obviously, like a directory is something like which holds many other files or many other directories, right?
Yeah.
Right. You cannot do a VI. You cannot just simply say cat onto the folder. You cannot view the content. You have to first do a CD onto it, and then you have to run a ls command to view the content.
Got it.
Right. Directory, you understood, right? See,
Yeah,
one more thing important I want to tell you, sir. The whole thing, the operating system, everything, your entire operating system, it could be Linux, it could be Windows, anything. It works on to the concept of folder or a directory only, sir. Your whole disk partition will be considered as a single partition, which is of it itself is like a folder only. Now, can you tell me if I go to the CD-ROM, sorry, if I go to the my computer, what is this C drive? It's a drive. It's a partition, right? Don't you consider this partition as a folder? Because when you do a double click on this, you can see so many files and so many subdirectories.
Yes.
So the concept of the file system starts with the folder itself. And whenever you're working on a folder, you need to have the read, write, and execute function.
Yeah, that's got it.
Clear, sir?
Yeah, it's clear.
I think you understood now thoroughly whatever I'm trying to tell, right?
Yes, I got it.
Any other guys? Any other answer or any other thing is floating in your mind?
Yeah, I just have one thing to add here. I don't think write permission is required in order to CD. You need read permission and execute permission, without which you cannot do CD and LS. Write is only required for creating a file.
Creating a file or a directory. Yeah.
Or to delete an existing file in
existing
directory.
file. Yes, right.
So normally the owner will have RWX, group will have just R and X. Others may not have anything, or depending on the use case.
Right. See, that's what. See, they have set some default UMask values, sir. We have to follow the UMask value, what the person who has designed the operating system, right? We have to follow that what they have given it. But in industry, it's not like the same default UMask will be there. They can set some other UMask value also, right? Based on their requirement. Right. So the UMask is by default comes with the system. Whatever they have designed, we have to just it will use the default UMask value. In my company, right? When I was working in the previous organization, there the UMask value is different only. For the root user or for the normal user, it was not 002. It was 0022 or 0 or 222, something like that. It was there. So you can change it later. No issues. Okay. Yeah. Sure. Okay. So coming back here where we were. Yeah. So that's how the permission it understands with this 9 dashes, which is very important for us. Now we understood that permissions are given, and whenever you want to change any permission or any type, any other permission apart from the default permission what it provides, right? Then you have to use a command chmod, change mod actually, right? So you need to change any permission with the help of a chmod. So for example, in J, it is having a read write for the owner, read write for the group, and read for the others. Suppose you want to change all the permission, read write execute for all the users, then you run the command chmod 777 and specify J. For simplicity, I'm saying you run this command and you do lsf and L. Now you could see that you have changed this permission. So 7 read write execute for the owner. Already read and write was there. It has added that execute now. Read write execute for the group. Already read write was there. It has just added that X, and read and execute for the others. Right? Write and execute, sorry, for others. It has added. So the whole owner, group, and others, you are given a complete new permission now by using chmod command. So here you can give the value itself like this. Sorry, value itself like this, chmod 777 day, or else there is another way how to do it, because for the owner or for the user, what is it actually? What is it? I forgot it. You for user or the owner we say, a group is like B we say, and other is O we say, right? Now you say that, Rajesh, I want to give the read write permission for the owner group and the others, all the permission, then you can use like this chmod, what is it? User, group, and others, right? O, what is it? RWX,
Yes.
something, yeah, and give that JFL. Yeah, you can do like this also. Or you'll say that, Rajesh, I will do for the user, I will do read, write permission, read, write, and execute permission. For the group, already read, write, execute is there. I will only give the read permission, execute permission. For the other, I will give, what is it? Execute permission, something like that. For the JFL, you can change like this. So either with the number you can play around for giving permission, or either with the numeric, the alphabetical value, whatever you have, right, that you can use it for giving a permission.
Yes. Yes, sir.
Okay, now. Okay, ch own, the chgrp is there. One more command is there. What is it? Ch own is there, which we'll see later, right? So you could see that actually here you are having Ubuntu and Ubuntu. This Ubuntu is a user ID and this is a group ID. Whenever you want to change the user ID, group ID, there is a command, the ch own command, which we'll see later. Change the ownership, basically, right? If you want to change the ownership of the file or a directory, you can use a chmod command. Sorry, ch own command to change it. We will see it later after some time. After I create a user, right, a new user, I will see that I'll be sure I'll be changing the ownership of that file by using a ch own command. Okay, this is also very important. In a real time, we use a lot. What is the use case when we use a chmod? I will tell you. A ch own, I will tell you after some time, right? Okay, good.
Sir, in which condition we can use the CH1?
Ch
Why we
Yes.
use CH1 is
ch1 is something like, for example, you are copying a file from
okay.
one directory, from one system to other system server.
Okay.
So, for example, you are logged in as a user, but when you're trying to copy a file, like that file might be having something like a root privilege.
Yes.
Now, when you try to copy, it will try to copy, and it will say user ID, group ID will also be root only.
Okay.
But you are a normal user. So then what happens? If you are a pseudo user, you have to change back to a normal user, to your user, and then you have to make use of that file, whatever the file you have copied it.
Okay, sir.
So always when you copy from other system, you always try to check what is the ownership is given for that file. When you try to copy from other system to your system, when you do SCP command, later you have to check it out.
Okay, sir.
If it is changed, then you have to rechange with the help of ch1 command.
Yes, yes, yes. Thank you.
Rajesh, can you
Okay,
please
guys.
repeat once?
Yeah. Sorry, we'll take a break. Huh?
Okay, sure.
Sorry, what you're asking?
Can you please repeat once that use case?
No. What I'm saying means actually what Milan is asking, when we use ch1 command, when we use it, usually what happened, guys, there is a system is there. There are two servers are there, right? There are two servers are there like this. Server 1 and server 2. Many times what happened, right? Server 1 will be having some files actually. Server 1 is having some files, and server 2 requires it. Suppose you're sitting and you're working on server 2, and you're having some files here, right? Some files is there, right? Say for example, some file is there, something like just something I'm just saying, Vasu, I'm taking name, Vasu.txt file is there, and the username is something like Ram, something. This is not user ID and group ID. Now what will happen, right? When you log in, when you are working under this server 2, maybe what happened, right? You might not be working as a Ram, right? You will be working like a Uday colon Uday. Uday as a Uday user, you are working, but still what happened? You want to copy this file Vasu text to this folder. What you will do, you by sitting on the server 2, you will use a SCP command with the hyphen or option to copy that Vasu.txt here. So once you copy this file, once you get this file here, like Vasu.txt, Vasu.txt, it has copied a file, but if you see sometime what happened, the ownership would have changed. Like if it is copied to your system, still you could see when you do an LSFNL, you could see that Vasu.txt file. Sorry, man. Vasu.txt file is still having that user ID RAM, group ID is also RAM, something like. But right, but you are working as a Uday, you cannot execute this file with this user ID group ID, which is with some other name. So then what happened, right? You have to use a sudo chown, right? What is it? Uday colon Uday vasu.txt. Like that, you have to run this command. So what it will do that it will try to change the ownership like this. This is a common thing which we always see this thing in when you're working in your system, right? When you're trying to copy some file from one system, there's a great chance that the permissions, the ownership, and the group permissions will change. So then you have to rechange it back by using chown command. Clear? Ram?
Yeah, Raj.
Yeah, this is the common use case I have seen actually. There are many other are there. Like for example, you want to in your system only you want to RAM has a file, that same file, and you want to share to Uday. Okay, while sharing in the same system in the same server, you will share it, but still that file is having the RAM as a user ID and group ID, which Uday cannot execute it actually. Now what happened to Uday to change it? He need to have a sudo's permission. So he'll use a sudo chown and then say Uday colon Uday, and whatever the RAM has given that file, he will give that file name. So it'll get changed, and now he can execute it. So whenever you want to execute any file, right? Whenever you want to execute or whenever you want to do any operation onto the file, that file should be in the same user ID and the group ID with which you have logged in. So here what happened? The root was here, the Ubuntu has logged in, right? If I execute ID command, the Ubuntu has logged in. And when I create any file or a data, anything, it'll always by default give the user ID and group ID with the same name with which user you are logged in. Sometime what happened, you need to change this user ID and group ID. Then what happened, use chown command. Even though if you're within the system itself, you're copying from one user to other user also, then also you have to change. Or else you're trying to copy from some other server, like by using SCP command or by using other methods, RCP command, you want to copy it. While copying it, the ownership might change. So when the ownership will change, then you have to use chown. Simple. Clear?
Yeah, Raj.
Okay, sir. So what we can do, guys, can we give a 10 minutes break and then we will quickly come back and we will continue from where? We will continue from this. What is this hard link and all is all about? Hard link, soft link, and a few other things. And then we will revisit again few more commands. And I thought that I will try to show you a simple C program and to write a simple shell script. We will see it today. If possible, we'll cover it today. Just take 5 minutes break and then come back.
Okay, sir. I am going to office and I will join from mobile.
Sure, no issue, sir. No
Okay,
problem.
sir. Yes,
Thank
sir.
you.
Thank you.
Okay, guys. So what I was saying that actually that here, if you do an LSF and L, you could see that actually the first column will give you the permissions. The second column will give you the hard links actually, or it gives you the information about link. So in case of types of files, the third type of file is a hard link and the fourth type of file is soft link. What is this hard link and a soft link? Very important. In many of the interviews, they have asked this concept of what is hard link and soft link. Hard link is something like it is another copy or it's a duplicate of the same file. Say for example, here, let me create a file by name Alice. I'll just use a touch command Alice, right? I'll use a VI command. We have not yet come to the VI editors, guys, but I'm just trying to tell you that how to use a VI command. You have to open with a VI space and this file name, open it, go to the insert mode by pressing I and just start typing the text, whatever you want to type it, right? Once you type all the text, just to do an escape to come out from the insert mode, then do a shift colon W2. W means save, means quit. Exclamatory means forcibly. Forcibly saving and quitting from the file. So how to do it? We have to open the file VI Alice. Whenever we want to open the file or whenever we want to view the content of the file, you have to use some editor, which we call one of the editor is a VI editor. So I have to say VI space Alice and so open it, right? So this file is open. Now I have to insert or I want to start typing some text inside a file. You have to get in insert mode by pressing I button. You'll get into the insert mode. Now you go to the next line and you can start typing. Once you complete the typing or once you complete whatever you want to write it into the file, you want to save a file, first you have to press escape. Escape will make you to come out from the insert mode and then use a shift colon W2 exclamatory. This is the simple operation which you did it now. So whenever I want to work on the VI editor, I have to open a file, VI, write some text in the file, come out from the insert mode and then save and quit it. We will see it elaborately in the tomorrow section, right? So this is what I did. I opened the file and I added some text inside the file. If I want to only view the content, I can just say at Alice. It will show you the content of the file. Okay. Now what happened? You said that Rajesh, I want to view the file, open the file. I can open the file with the VI also, VI Alice. Okay, I went through the file, but I don't want to write anything. I want to just quit it. I want to just simply quit it. There you have to say shift colon Q exclamatory. Quit forcibly. Yes. So shift colon W means save and quit it. It means that suppose you have written any text inside a file, then you need to save and quit it. So shift colon WQ exclamatory means. Right? And say enter, you'll come out from that file. It'll save and quit from the file. Right? Now I have a file Alice. Now if I want to see the inode number of the Alice, I'll say ls-I Alice. This is the inode number. Or if I run a stat command onto the Alice, so this is the inode number. Right? 262876. Yes, right? This is the inode number. Now what hard link says that whenever you have a file, you can create a hard link for the file. Right? Say for example, if I use a hard link ln command, Alice is the original file, Bob is hard link file, and enter and say ls-l or ls-l. Can you see Bob file has created now? Bob is a hard link for the file Alice. Right? Bob is a hard link for the file Alice. So now whatever the Alice contain, even the Bob also contain the same text. Right?
So it
now
will copy the content of Alice file into Bob.
No, it will copy the content, but the stuff here in the hard link is that actually both the hard link files are having the same inode number. If you do ls-I to Alice and Bob, can you see the inode number are same?
Okay.
So both the files are pointing to the same inode. So it means that you can say that actually it's a copy of the same file. Right? Now, if you remove the original file, say for example, you say Rajesh, you open Alice file, you add some text inside the file, some extra you added and save this file. Does it reflect to the Bob also? Yes, it reflects to the Bob also. Why? Because that both this file, Alice and Bob, are pointing to the same inode number. Right? So it means that if you edit any one file, other file also will get reflected because both are pointing to the same inode. Rajesh, why we have this? For safety purpose. Suppose you have some important file, you want to keep another copy of the same file, then you can use a ln command. So why you are doing that? Suppose you remove the original file itself. Mistakenly, I will do rm Alice. You remove the original file, lost the file, but Bob exists, right? You can recover the data, right? So for that reason, what happened usually in the organization, some important files, they will keep a hard link of, or they'll keep another copy of the same file by using a ln command. So how you created a hard link? Ln space Alice space Bob, right? Ln command, hard link. Ln means hard link. To create a hard link, ln command. Now, what are the important points we have to say for hard link? Hard link, the important files are hard link can be created only for normal file, not for directory. You cannot create hard link for a directory. Say for example, you're having a Kailash or you're having a Vasu, right? Now I'll say ln Vasu, and I will give the one more folder by name Kiran. I'm creating a hard link for the Vasu. See, hard link is not allowed for a directory. So the first point is that actually that hard link can be only created for a normal file, not for a directory. That's the first point in hard link. Second is that hard link, when hard link file is created, both original file and hard link file will have the same inode number, right? When you're creating a file, obviously the system has to, or the kernel has to allocate a new inode for the file. But here what happened, we are using ln command to create a hard link, but hard link, what it says, not to create or not to assign any new inode. The same inode, whatever the original file has, the same inode will be used for that file, right? And the third important point is that actually that you can create a hard link, okay, within that partition. It means that hard link cannot be created across partitions. So suppose assume that in our case, I'm having a C drive, I'm having a D drive. So you say that Rajesh, there's one file in C drive. I want to create a hard link of this file, which is then C drive in the D drive. You cannot create it. Hard links cannot be created across partitions. So similarly in Linux, we can have so many partitions. Like for example, slash partition, slash USR partition, slash var partition, slash boot partition, right? Right? What other things are there? You can even create a separate partition even for your slash home also. So suppose if you're having this many number of partitions, 4 to 5 partitions are there. Right now, we don't have that much of partition. Assume that we are having so much of partitions are there. And you will have one file which is then the slash, or which is then the slash USR, a file. For that file, which is then slash USR, you want to create a partition, you want to create a file into the slash var as a hard link file. You cannot create it. It will not allow. It is that it gives an error, throwing error saying that partition, hard link cannot be created across partition. Like that, you'll get an error when you are creating it. Right? So these 3 important points you have to tell during the interview. So these 3 points you have to tell. Opposite of hard link is a soft link. So what the soft link says? Soft link, or we can call it as a symbolic link. Both are same. So what it say that soft link can be created both for normal file and directory. Soft link, when you create a soft link file, a new inode is allocated to the newly created soft file. Third point is soft link can be created across partitions. So in soft link is something like a shortcut, what we see in Windows. You know, right? If suppose your filing is there somewhere under the D drive, there is a folder by name Rajesh. Under the folder, there's a folder by name Ravi. Under that, there's a file. So every day, whenever you want to navigate it, you have to go to the D drive, you have to go to the Rajesh folder, then you have to go to the Ravi folder, and then you'll find the file. So instead of can I keep that file in the desktop? Yeah, you can keep it. That we call a shortcut. It's same thing like that in Linux. It is soft link or symbolic link. So now come back here. Let me remove that Bob file. Bob file, and let me open the file Alice. I'm creating a fresh new file with a VA command Alice. Like this, I added these 2 lines and I saved this file. Right? I saved this file. Alice file is there. Now, if I want to create a soft link for the file Alice, I'll just say ln-s Alice Bob. Right? Whenever you want to make it a soft link, you have to use a -s option. Earlier for hard link, there is no option, only ln command, ln Alice Bob, space Bob. Now ln-is Alice space Bob, like that. Enter. Now if you do a ls-l, can you see that Bob has been created? Bob is a file which is actually pointing to the Alice file only. You could see that for the symbolic link of soft link, it always represents the L. L means it's a soft link file. So if you do a ls, can you see Bob? See, it is something like a sign in color, CYN, sign in color. So whenever you see this type of color of file, you have to quickly understand that it is a soft link file. It is a soft link file, right? Now, if you go to a folder, something like cd2/usr/xbin and do a ls, you see there are so many soft links are there. See, right? Now, when you do an ls-l long listing, can you see? See, VG extend is actually pointed to the LVM. VG export is actually pointing to the LVM. So most of the soft links are pointing to the same LVM command. So why we are using like this, I will tell you after some time, not now. If I tell you, you will get confused actually. Right? So like that. Okay, what about the MKFS? Somewhere you saw Rajesh, MKFS something. Let's see what is it. See, MKFS.dos, MKFS.ntfs, MKFS.vfat. See, this is a soft link file to the MKFS.fat. This is a soft link for MKNTFS. This is a soft link for MKFS. See, like this, these are the soft link files which are being created. What is the usage? It's like a shortcut, as I said, right? But there are other use cases are there. Why we have the soft links and all, I will tell you after some time, not now. So first, soft link can be created both for normal files and directory. Soft link, whenever you create a soft link file, a new inode is allocated for the soft link, right? Now, when you do a stat of Alice, you see it is showing you the inode number. This is the inode number for the Alice. When I do a stat of Bob, you see the inode number has changed now. It means that whenever you create a soft link file, a new inode is allocated for the Bob file. So it means that it will try to create an inode. It means that it itself is a separate file. It is something like a new file actually, but so it's a new file with a new inode number. But what is the characteristic of that file is that actually that file is a pointer to a original file, which is Alice. It's just like a pointer. So now, if I try to do a cat of Bob, you can see the content of your Alice itself. Suppose if I open the file Alice, right, and if I try to add some more content and save it, right, and when I do a cat to the Bob, can you see even it shows you all the changes? Because cat is something like it is pointer it actually. Sorry, Bob is actually a pointer to the Alice file. So what the Bob contains? Bob contains the inode number of the Alice itself. It contains the inode number of the Alice itself. Actually. That's the reason if you do an ls-l, you see the size of the Bob file is 5 characters. What is that 5? ALICE. This 5 characters is there, no? This is what it is showing you the size of that Bob as a file itself. So it means that this Bob file will actually contain it has the information about the Alice file, where exactly Alice file is located or where exactly the inode is located. So this Bob is actually pointed to Alice file. Now the point here is that actually if you remove the original file, you are losing that link. You cannot recover the data. Suppose if I'm removing RM Alice, see, you're removing the original file. So if you do ls-l, can you see? Bob is actually pointing to Alice file, but that Alice file itself is not there. Now, Bob is pointing to an address where the Alice file exists, but that file itself is not there. It means that it cannot fetch any data from that address. Then what happens? This Bob, it is something like a dangling pointer, we say. So it has a pointer to some address, but that address doesn't exist. Then that pointer will become a dangling pointer. Right? What is it? Dangling pointer. Right? A pointer pointing to memory location that has been deleted or freed is called a dangling pointer. So it points to a file, but the file doesn't exist. So then the Bob will act like a dangling pointer or a dangling file, something. Any questions you have? Vinod?
No, I just asked what was that, and you mentioned. Thanks.
Okay. Oh, I'm sorry. Vasu, can you please unmute and ask? Yeah, I mistakenly muted you. Yeah.
No problem. So for hard link, we'll have that copy file, no, sir? Like,
it's a copy. It's like a same copy.
Yeah, the same
But,
inode.
Yeah, it's something like this actually. What is it? Something like that. This is the file actually, right? This is inode. Sorry, this is inode. But you are having two files actually, like this, Alice and Bob, like this.
Yeah.
Yeah. So both are pointing to the same inode actually. Sorry, both are pointing to the same inode like this. Alice also pointing to the same inode. Bob is also pointing to the same inode. That's the reason if you remove any one file, other file exists.
Yeah.
You can recover the data. So this is Alice file.
And it is same for the directories, no, sir? Like we can't.
We cannot create a hard link for a directory, but where a soft link can create it. That's what I'm saying.
Oh, okay. For soft link, we can create.
Okay. So this is all about, this is what the difference you have to tell if they ask an interview. Now, when you come to the ls-l, now whenever you create a directory, Vasu, Kailash.
Just sorry to interrupt you, Rajesh, but the small correction there with respect to hard links, there are no multiple files. There is a single file.
That's single. It's another copy of the same file, sir. You can see.
No, the copy is never created. There is no copy.
Copy means you are creating it's like an alias you are creating, we can say. Another name of the same file.
Yeah. So there is only another directly link created. There is only a single file.
Yes. See now what happens.
Copy, like, when you say copy is only created with CP command, where two actual different files will exist.
Files will be there for the different, even though the file contents are same, but both the files will be having a different inodes.
Different inodes, yes.
Yes, but here what happened
is the same. There is only
a
file.
Yes, yeah. To make it in a simple English conversion, I said it's a copy, or it's a copy. I said actually, copy doesn't mean that actually I'm running a copy CP command. In a plain text English, I'm saying, sir, that it's a copy of the same file, but both the files are pointing to the same inode.
No, there are no two files. There is only one file.
Correct, sir. But what is up now? See what happened now. Even the Bob also has an existence, right? See,
Bob does not have existence.
Now,
Bob is only an entry in the directory where the hard link is created. That's all Bob's existence is. There is no other existence for Bob. So when a hard link, if you can create 25 or 100 different hard links, there will be only a single file, which means no disk will be used. Disk blocks.
No, disk will not be used. That's
only
correct,
you can create, if you create 100 different links in 100 different directories throughout the same file system or the same partition. In each of the directory, there will be an entry pointing to that inode having a different name which you have given to the new link. That's all it happens.
No, that's what I agree. Whatever you're saying, what I'm saying, to make it a simple way of understanding, I use the word copy.
Okay,
but it's not like a copy. It's like another name of a same file. I'm saying.
Yeah, another name for the same file. That's
another name for same. See, if I tell like this, it's another name for the same file. Then the people will start asking question. What do you mean by another name of the same file? So because that's the reason what happened. I just said it's a copy of the same file. If it is a copy, definitely. It cannot be a copy actually, because when you have a user copy, it means that it should have a separate inode. So we cannot say like that.
Saying that same content. Copy means same content.
Yes.
Sir, I got it out here. Like
that is a replica, right?
Yeah.
Like Bob is not a copy, then when you remove Alice, Bob will exist to the same inode, no? So
Still, Bob exists, sir. Bob exists actually.
yeah,
Yeah, it's an entry that exists actually. See, it's something like a you're creating one more link, an extra link. That's all. You're creating one more extra link when you're using a hard link. That's all you have to understand, right? But even see that also represents a file only because you're doing an operation onto the file. You want to view the file. You want to do it. You have to run all commands like va command, cat onto that file. It is a file itself. It is a file, no doubt. It's like another extra link you have created when you are using a ln command. And that link you can create it across anywhere within the same partition. In any folder, you can go and you can create that link. It supports. Because that inode, whatever the inode which is there, it exists in that particular partition only. Wherever you can go, whichever folder, wherever you go and whichever path you go, they're sitting there in the particular folder somewhere, you can create a hard link for that original file. But it should be within that partition. And it's not like a copy, it's another name of a same file. Or it's like an alias of alias, you can say. What is alias? I will tell later. It's like another it's like another name of a same file. Like that you have to understand. Okay. So guys, there's nothing like complexity in this understanding. Only plainly you have to understand, okay, it's another name of the same file. That's all. Don't break your head much into it.
Yeah, I remember one of the interview questions quite some time long back was when I was asked, so after creating multiple hard links, how do you identify the original file?
It's the how it's as per my knowledge, you cannot identify, sir.
Yeah, there is no such thing as original
Yes.
file because there is a single file.
Single
There are
file.
100 different names created for it.
Yes.
You can refer to the same file with all the names, any of the names. So whenever you remove a hard link, you're simply removing that name linked to that inode. One entry in that directory will get removed.
Removed, that's all. Yeah.
So remaining links are anyhow there.
Yeah.
That's
Right.
all. So there is no such thing as original file. It can never be identified.
Correct. Right. See, original file is there, but what happened during the process of creating many hard links actually, like you might not really say which is the original file through which you created a hard link.
Yes, exactly.
Yeah. Because to create a hard link, there has to be original file, right? There has to be a file. Then only you can start creating it. Otherwise, you can't create it. Right. Anyway, it's a good interaction. Okay. Guys, what do you say? Should we stop it or we'll continue for 10 more minutes? Because whatever that today's agenda was there, like I couldn't complete it, like it will be gone, it will be going tomorrow. But this weekend, what would be my main focus would be that I will be covering up in these two classes on Saturday and Sunday. I'll be covering more on the scripting one, 2 hours, so that we will try to learn some basics of scripting and few other scripts, important scripts we'll execute and we'll see it. Later, there are many other scripts are there which I'll be sharing to you in the weekend when I share you the drive. In the drive, I will keep all the scripts. So you please practice all those scripts, whatever I gave it. Right. So we cannot really show you the full-fledged scripting class over here. We have to basically understand, like whenever I want to do automation, how I can write a script and what are the programming construct I'll be using to write a script. Only that much is sufficient for us. After that, you can drill down your own way of learning script in a in a very higher way. And I'll share you a lot of documents, videos, and many other things, so we can start going through it and learn in an effective way. Okay, once that is completed, then we will have a set and awk session for one class. I will call you on Monday, something so that you can sit for 2 hours, 8:30 to 10:30, 1 hour set and 1 hour awk, and we will try to finish that one. So from Tuesday onwards, we will see the networking, right? How the networking works, the basic essence of networking, all those things will cover from the Tuesday onwards. Right? If it still takes some more time, then I will take from the Wednesday onwards. So just 1 or 2 classes here and there, we will be you'll be front or back actually. But yeah, I will try to cover whatever we have planned, right? We'll cover everything. So moving forward, I'll be showcasing many other commands are there, guys. In tomorrow's session, what happened? My main focus would be that to complete that there are different types of files. In 10, 15, 20 minutes, I will cover it. After that, we will try to learn many other commands, very important commands which are there. And then we'll learn into how to, what are the shell features and all. And then like syntaxes and all, we will learn about those shell features. And then like we'll start learning like how to write our first shell script. Before the first shell scripting, I'll write a simple C or C++ program, show you how to compile and execute it, and then explain you about what is the difference between a compiler and an interpreter. So because C or C++ or any other Java, or these are high level language programming. So whenever you want to execute the program which is written in high level language programming, you need to get a compiled code actually. So to get a compiler code, you need a compiler. So all these languages are you need to compile so that you can start executing that program. Whereas a Bash, Python, Perl, anything, these are interpreted languages. So we need to learn or understand the difference between what is a compiler, difference between compiler and an interpreter. So that's the reason I want to showcase like how to write a simple C or C++ program, how to compile and execute it, what exactly the compiler will do. You have to understand that. And then what the shell or the interpreter will do. Then just distinguish the difference between these two and come up with some points like how you can define or how you can differentiate between a compiled code with the interpreted code like that. So that is a basis for us to understand how the interpreted, like tool like Bash shell or Python, how it works. We need to understand that. And then like whenever you run any script, how the script will get executed by your Bash shell, right? That we have to understand. Once that is done, then we can happily go with learning the shell scripting part. Clear? So as I said, like I will not be fully covering the whole shell script because it is not required as of now. Only very important things I will cover it up. Other scripts and all I will give you to explore so that you can go and you can run that scripts and you can understand the scripts. And also I will share many PDFs, guys. You have to start reading the first script actually. Like I will give the script, but just try to see the script actually. See, Linux shell scripting by Vivek Guide. So you'll get a PDF or else. So this is the PDF you'll get, guys. So this is a very good PDF actually, which is written by Vivek Guide. You can go through this PDF. He has explained it very well. What is a Linux kernel, file management, multitasking, memory management, IO management? What is Linux shell? So shell is a user program. Okay, it provides an environment for the user interaction. So this is a very good PDF. Just try to type this and you get this PDF. Apart from this, there are hundreds of PDFs are there which I'll give you. But what I would suggest that read one PDF at a time and try to finish it. Don't read multiple PDFs, multiple articles. It's not like it will confuse you. It will consume a lot of time. It will not confuse you. You will learn many things, but you don't have time. Just stick it to one document or one PDF and then just go through it completely. That is sufficient for you to get into understanding, better understanding. Later, once you get a time, you explore many other articles, PDFs and all. It's left to you how you can explore more, how you can learn more. Means you have to undergo many articles, many documentation, right? Like that when you will learn. So you need to learn through multiple sources so that you will get some different ideas. And then collectively, once you get all different ideas, collectively you can take it up and you can summarize and say that, okay, this is the concept actually behind whatever you're learning. See, why we are referring to multiple articles, multiple authors articles, or why? Because that to make your understanding better. That's all. Whenever you want to learn any concept, maybe you might not learn through one PDF or through one article. You might refer to multiple articles. So in a different articles on different PDF, people, authors have written in a different way, right? So when you collectively go through all those things, right, you'll able to understand in a better way. That is the only reason. So, but initially you have to stick to one PDF on one article, read it completely, understand it, and then like you proceed further. Clear? So I will not see. I will not I will not give you more saying that okay, you read this PDF, read that PDF, because it will confuse you, and there are so many things are there to read. So I will not suggest that no, always depend upon the articles only or read the PDFs. No, not like that. Some important points are there which I will say that okay, you go to that PDF, in that page, that article is there or that concept has been explained. Please go and read it. Just go to that PDF into that page, read that blah blah blah, and come out from that. Now, how you can effectively learn very faster means you solely depend on the video, what we are working, what we are doing. Practice those videos, go through those videos 1 or 2 times, practice yourself, get hands-on, learn the concept very well. This is the initial thing which you have to do for every DevOps tools or even for every or to any cloud. solely depend upon the video, go through it and do it. In each and every video, I will say, okay, this is the article which I have read it. I got this article, some good information are there. Whenever you get the time, just go forth to the articles and PDFs and read it and come back like that. That is required, sir. When you are reading, when you're understanding the concept, you need to do reading and also you need to even watch the videos also. Both you have to do parallelly, right? Because there are many things are where people will understand the concept very clearly when they go through some articles written by some person. They will like it actually, and they will learn that concept very well. But whereas sometimes what happens in the video, you might not get the complete understanding because the author might be saying it, but he might not be giving a complete information to you. He might only be sharing some information which is required, the most important he might share you. There are many other hidden informations are there which he might not tell in the class. Even I might not tell in the class. You will get all such information, everything in the PDFs or in the articles. Right? Do you agree with me with this? What I'm saying? So make a habit of reading also, which is very important. Make a habit of writing your own notes. That is also very important. Clear? Okay, guys. Thank you. Then
So,
I think, yeah.
Rajesh,
Yes.
yeah, so I think you can stop the recording. I think this is regarding that question, right?